Well, greetings, Mr. Kolazar's class. We're going to continue with types of reactions. Remember, this is on those back 2 pages of your notes. So, as we're going, what we're going to look into now is single replacement reactions. A lot of times you hear single displacement also. Replacement and displacement, same thing. Reaction in which atoms of one element replace atoms of another element in a compound. So what we're going to have is one atom come in and kick another atom out of a compound. Metals replace metals. Nonmetals replace nonmetals. Only occur if the element is higher on the activity series. Now that's going to come up on our next slide of information. So our general equation, you have an element coming in and it's going to remove and kick another element out of a compound. So an element is going to remove or kick out, and so that new element is going to be by itself. So A is going to replace B in this case in our general equation. Now from there, our activity series, check your gold packet real quick. On your gold packet, I believe it's on that front page, the most active elements listed up at the top. The most active elements are going to replace a less active element. So lithium, most active of our elements, is going to replace anybody else on this chart. And as we move down this chart, the elements get less reactive, and so they're less likely to replace another element in our reaction. Gold down at the bottom here, very unreactive, and so as we're going, since it's very unreactive, gold will not replace anybody else in our chemical reactions. With our nonmetals, fluorine, chlorine, bromine, and iodine, fluorine's our most active of our nonmetals, and then it continues on down to less reactive. So if an element is above, higher up on, it's going to replace. So to try a couple examples out, zinc solid plus copper nitrate is going to produce, now in this case zinc's our metal, zinc is going to move in and replace the other copper metal. So zinc's going to move in to replace, so we're going to end up making zinc nitrate and copper metal. And now as we're going, zinc, to find out does this reaction work, zinc is right here, copper is down below, zinc is more active. Since it's more active, it's going to replace copper in the chemical reaction. Now if we look at the second reaction, magnesium and calcium phosphide, calcium is a metal, magnesium a metal, so magnesium is looking to replace the other metal. If we were to check out our activity series, magnesium and calcium, calcium is more active. Since calcium is more active, what it's going to do is it's not going to be replaced by the magnesium, a less active element. So in this case, you don't even have to work through this reaction. Since magnesium won't replace calcium, we're going to say NR. That's also known as no reaction. So this reaction would not take place. We're going to stop there, and you can work on the other 2 problems on single replacement.